Hi, Integrated Math 1. Welcome to lesson 4.1.2a. So we're doing module 4, topic 1, lesson 2, and we're doing the first day of it. So we're going to do activities 2.1 and 2.2 today, and we're going to start just by talking about how we analyze data, all right? So we're on page 4, M4-19, if you're curious where we are. So you can analyze a data set by describing numerical characteristics or statistics of the data, right? So what's characteristic of this data? We call those statistics. So a statistic that describes the center of data, right? If the characteristic I'm looking for is what's the center of my data set, we call it a measure of central tendency. And a measure of central tendency is a numerical value used to describe the overall clustering of data in a set. Like, where is our data clustering? So when we're looking for a measure of central tendency or the center of our data, when we're looking for that statistic, we're looking for where is our data clustered around, all right? Two measures of central tendency that are typically used to describe a set of data, to describe that where our stuff is clustering, are the mean and the median. We've talked about these words before in class. You've messed with these a little bit when you were in middle school, actually, but we're going to really dig into the mean and the median today. We're going to really get into those guys. So just a few brief reminders about mean. We're going to talk about that. First of all, we have this lovely dot plot in front of us. A gym surveys its members about the average number of hours they spend at the gym each week, and the data is recorded on our lovely dot plot. Dot plots are great when you have kind of a small amount of data that you're looking at and when you have very specific numbers. And so this is a lovely dot plot, and you can see that it looks like we've got some clustering down here, but we have a few weirdos hanging out on the end. I shouldn't call them weirdos. They're perfectly lovely people. That person that's spending 32 hours at the gym each week, they're probably pretty ripped. I shouldn't judge them for that. So again, when we're looking for a measure of central tendency, when we're looking for where our data is clustering, one of the things we can use is the mean. Now, we've talked before about how you find the mean, how mean is just average. You've heard that before, but we're not going to use the word average anymore. We're going to be using the word mean, but you know that mean means find the average. So to describe the mean of a data set, we're going to calculate this little guy, which we call X bar. So I have this X with a little line on top of it. That is the mean. So when you see this, when we're finding the mean, when you see this, we know, and I'm going to make a quick note here, we know that mean means find the average, and we use this. So whenever you see X bar, that means that we're finding the mean. All right, I feel like I've now used that word a whole bunch of times. You know how to find the mean because you know how to find averages. You know that you add them all up and divide by how many there are. So I have some magical, lovely notation to help us out with that. So you know how to find the mean. You add up all your numbers and divide by how many there are. This is a nice mathematical way of writing the formula. So this little guy on top, this little E looking symbol, it's actually the Greek letter sigma. Sorry, my lights are going out on me here. It's actually the Greek letter sigma. And in mathematics, it means summation or find the sum of. So don't freak out over this little E looking symbol. It just means you're finding the sum. You're adding them all up because that's our Greek sigma. So you're going to add up all the data values. That's why this little sigma X is the sum of all the data values. You're going to add everybody up. And then, of course, underneath, we're going to divide by n, where n is the number of data values, how many we have. So you know this. You know you find average by adding them all up and dividing by how many there are. But now we have this really cool notation where we have X bar for our mean, and then we use sigma X for the summation. So I'm not writing this plus this plus this plus this. We're just going to write sigma X, and we'll divide by n, our number of values. So for example, if I have 5, 10, 9, 7, and 5, I can find the mean of this data by doing the sum of all of those values, so 5 plus 10 plus 9 plus 7 plus 5, and then dividing by the number of those values. And I have 1, 2, 3, 4, 5 of them, so I will divide by 5. I can grab my lovely calculators I'm like throwing around. 5 plus 10 plus 9 plus 7 plus 5. So I end up with, and they didn't write it all out, that means I end up with 36 divided by 5. And we'll go ahead and divide out the 5 because that's how many there are. And we find that X bar is 7.2. So the mean of this data set is 7.2. Now, you already knew how to find this. This wasn't a surprise, but we just have some cool new notation for that. So when you see this whole little X bar, don't freak out. You're just going to find the average. That's it. You're going to add them all up, divide by how many there are. So you know how to find mean. Mean is not new to you, but you guys also remember median, right? To describe the median of a data set, you need to determine the middle number in the data set. But remember, this is so important. I mean, yes, it's the middle number. You know the median's the middle number, but please, please, please remember, the values have to be in order from least to greatest or greatest to least. Your values have to be in order. So looking back at that data set we had before, 5, 10, 9, 7, 5, if I came back here, so 5, 10, 9, 7, and 5. If I wanted to find the median, the middle number, the first thing I need to do is I've got to put these guys in order. They are not in order right now. So I'm going to put them in order least to greatest. So I actually have 5, 5, 7, 9, and 10. My median is the middle number, so that means this guy right here in the middle, that would be my median. So my median for this data set would be 7. So the mean was 7.2 and the median is 7 for this particular data set. So here's what I would like you to do. Here's what I want you to do. We did box and whisker plots, right? Where we had to do our 5-number summary. We did that last time, where you had to find the median, and then you had to find the median of the first half and the median of the second half. We called them quartiles, right? You remember that? So we had minimum, we had maximum, we had our median, and then we had our first quartile and our third quartile. Sorry, I can say it right. I want you to find all those. I want you to calculate the 5-number summary for this data. And then I want you to construct a box and whisker plot that displays that data. And I want you to put it right up above, right up on top of your dot plot. So go ahead and hit pause, work out your 5-number summary, and then use it to make your box and whisker plot. And then hit play when you're ready to check your work. All right, 5-number summary. Well, if I'm going to do a 5-number summary, the first thing I need to do is I need to put these in order. So I'm going to put these in order. So I have 2, I have 3 5s, 1, 2, 3, 4, except I went too far. I only have 3 5s. I got carried away. I really like the 5s. I'll fix it. I have 1 6, I have a 7, I have a 9, I have a 10, I have 3 12s. Okay, so 12, 12, 12. I have a 14, and then I have that one really ripped dude that's spending 32 hours at the gym. Wow, that's impressive. All right, so I have them all in order. That was the first thing we needed to do. All right, so my 5-number summary, some of these are super easy, right? We know that this is our minimum. We know that this is our maximum. So make a quick note of that. My minimum is 2. My maximum is 32. So make a quick note of those. Median is next, right? We got to find the median. So I need to find the guy in the middle. Well, let's see here. If I'm like, not you, not you, not you, yeah, bump. I'm working my way toward the middle. Oh, there it is. So my median is 9. Okay. So median is, oopsie, just kidding, 9. Beautiful. And of course, we need the median of the medians, right? So my first quartile, which we call Q sub 1, he's the middle of these guys. So if we just kind of check the middle, so 1, 2, 3, 1, 2, 3, there it is. So there's our first quartiles at 5. And that means we're going to do the same thing over here. So 1, 2, 3. Oh, that arrow disappeared. 1, 2, 3. So it looks like my third quartile is sitting at 12. All right. Now I have all of my bits. I have all of my pieces. Let's do this box and whisker plot. We know we do vertical lines at every single one of these. So up above, I'm going to do a vertical line at 2. I'm going to do a vertical line at 5, a vertical line at 9. I have to put it way above here. A vertical line at 12, 2, and a vertical line at 32. It's like way out there. Remember that we do a box from the first to the third quartile. So the median gets stuck in the middle of our box. And then, of course, we've got whiskers, right? It's a box and whisker plot. So here's one whisker. Here's the other whisker. It's a really long whisker. I feel like that needs to get trimmed. Beautiful. Lovely. We have a box and whisker plot. Yay! Wasn't that exciting? Here, I'm going to erase all my work here, and you're going to see the like typed stuff, like the good stuff. Boom. It's a little prettier in mine, but mine wasn't bad. It was all right. So now that we have this lovely, lovely box and whisker plot, so that gives us the median, and that's really great. That's super useful. But we were talking about the mean as well. So what I would like you to do now is I would like you to calculate the mean of our data. And don't forget to mark that little X bar above that point on our number line. So once you find your mean, put a little X bar above it on the number line. Go ahead and hit pause to work that out and hit play when you're ready to check your work. All right, this is the easy one. You know how to find the mean. We're going to add all these up. So 2 plus 5 plus 5 plus 6 plus 7 plus 9 plus 10 plus 12 plus 12 plus 12 plus 14 plus 32. Ooh, and we need to divide, right? We're going to divide. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So I need to add them all up and divide by 13. Totally used a calculator because I don't know what that is. Definitely used a calculator. So when I added these up, I got 131. And when I divided by 13, I got about 10.1. So I'm going to put my little X bar over here above 10.1. So it's not quite 10. It's a little bit past 10, just the tiniest bit. So there's my X bar. Yay. You know, this dot and dot plot is interesting. The box and whisker plot was great, but this dot plot is interesting because remember this whole idea of looking for the mean and the median. The idea is we were looking for the center, right? We're looking for where our data is clustered around, what numbers our data is clustered around. So what do you notice about how my data is clustered? Hit pause, jot down some thoughts on that, and hit play to keep the discussion going. So I noticed that most of my data was between 5 and 14. Did you catch that? That most of the data is between 5 and 14. I mean, yeah, there's like a 2 down here, and that, again, the really ripped guy who's doing 32 hours at the gym. But most of my data is between 5 and 14. I also am going to make a note that while 2 is pretty low, I'm not going to judge anybody for only going to the gym 2 hours a week because it's more than I go. So I'm not going to judge too much. But I'm going to be judgy about this guy. Okay, dude, the guy spending 32 hours a week at the gym, get a job, okay? That is a very extreme value. So I'm just going to make a note here that that guy feels a little extreme. But the other thing I noticed is that I kind of have 2 peaks on my dot plot. Do you see that? How I have like a peak at 5 hours and a peak at 12 hours. So I'm going to make a note of that as well. That I got 2 peaks going on, which feels a little weird, but it is what it is. People do what they do. So when we're looking at the overall shape of a graph, we call it data distribution. When I'm kind of looking at the overall shape of my graph, where my stuff is clustered, that's what we call data distribution. So remember that there are 3 common types of data distribution here. It can be skewed left, it can be skewed right, or it can be symmetrical, right? Perfectly even. And the distribution of data can actually help you determine whether the mean or the median is a better measure of the center. Because we're noticing that our mean and our median is not always the same, right? We noticed, let me come back here, on part B, we noticed that our mean was 10.1, but we noticed that our median was 9. And so they're not quite the same, are they? So which one should we use? Which one is a better measure of where the center of our data is, of where our data is clustered? So we want to take a look at the shape of the data distribution. If it's skewed right, it is leaning right, people. If it is skewed to the right, then the mean is the mean of my data is greater than the median. So since it shifted a bit, that means that my mean is going to be bigger than my median, that my median is still going to be sitting kind of in the middle of my data, but the mean's going to get thrown off a little bit. So the mean of the data when it's skewed right is greater than the median. The median then is a better measure of center. When it is skewed right, the median is going to be a better measure of center. Because the median's not going to be really affected by those large data values, right? The mean is, but the median won't because he's just sitting in the middle. If it's symmetrical, then your mean and median are probably going to be equal, all right? If you have a nice symmetric data distribution, your mean and your median are going to be pretty close. They're going to be pretty similar. If it's skewed left, all right, so now it's leaning the other way. Do you like how I lean when I tell you guys about this? It's leaning, it's skewed left. All right, I'm leaning left. So now that it's skewed left, the mean of the data is now less than the median. That's the opposite of what happened when it was skewed right, isn't it? So my mean is now less than my median because I have all these smaller data values that are going to pull down the mean, but they don't really pull down the median too much. So in this case, once again, the median is going to be the best measure of center because it's not going to be affected by those small data values. The mean will, but the median will not. So looking at this lovely data set that we have here, ask yourself, which measure of central tendency should you choose to represent the data set? Should you use the mean or should you use the median? And you might want to look at which direction your stuff is skewed. Go ahead and hit pause, jot down your thoughts, hit play to keep it going. So I was looking at this and I was like, oh my gosh, that thing is way skewed right. Like it's really skewed right. Do you see how the box of my box and whisker plot is like, whoa, it's super skewed right. And so because it's skewed right, the median would be a better measure of the center. Yeah. I would use the median to represent the data set because that is way skewed right. Like we're leaning really far over there. You can see this, again, the long whisker, right? So we're definitely leaning to the right here. That value of 32 is so much greater than the other values. It really affects your mean. It doesn't affect your median, but it really affects the mean. So median would be a better one to use here. Darn 32, again, that jacked up guy, he's messing everybody up. So we've talked about our measures of central tendency and we've talked about mean and median. They're super important. Another characteristic to consider when analyzing a graphical display is the spread. Sometimes they refer to it as a variability of the data. But how spread out is your data? And one common measure of how spread out your data is the interquartile range. And because we don't want to write interquartile range over and over again, we will often refer to it as IQR because we're math people and that's what we do. So the interquartile range measures how far the data are spread out from the median. So here's my median. We said this is a good measure of central tendency. And so that IQR, that interquartile range, tells me how spread out are we from my center. It's calculated super easy, so easy to calculate. All you have to do is take your third quartile and subtract out your first quartile. So if you got your 5-number summary, super easy to find the interquartile range. You're just going to subtract that third quartile and that first quartile. I do want to point out real quick, we did box and whisker plots last time. You do realize then that interquartile range, that box in the middle, half of your data is sitting in that box, right? That interquartile range is the middle 50%. It's the middle half of your data. So just keep that in mind as well. And of course, if the median is the better measure of center to use, which we noticed skewed right, skewed left, median's the better one to use, then we should really be using the interquartile to describe the spread. So if I'm like, hey, this is skewed right, skewed left, median's better to use, and that means when we describe the spread, we really want to be using that interquartile range. And a box and whisker plot is great because it provides all of these pieces of information. I love it. I love it. So I would like you to go ahead, go back to that question 1, go back to our box and whisker plot that we made earlier, go back to the 5-number summary that we wrote down earlier, and I would like you to calculate the interquartile range. Go ahead and hit pause to work that out. Hit play when you're ready to check your work. All right, people. Interquartile range, you just need your third quartile and subtract out your first quartile. If you go back to the other problem, we wrote that stuff down, right? We wrote down that our third quartile was 12 and our first quartile was 5. So I'm just going to do 12 minus 5. And it turns out my interquartile range is 7. So that kind of tells me how spread out things are from my center. Here's where the interquartile range is going to get a little crazy, but trust me, it's a good thing. Another useful statistic when analyzing data is to determine if there are any outliers. It's important to identify outliers because outliers can affect my other statistics of my data, right? Outliers are going to mess with the mean. And if you're not sure what I'm talking about when I say an outlier is a data value that's significantly greater or lesser than other data values in the set. And I think you know which one I'm talking about when we're talking about those gym memory, the hours spent at the gym. You know who I'm thinking of. Yeah, so an outlier is one that's like way too big compared to the rest of the data or way too small compared to the rest of the data. So that's what we're talking about when we're talking about outliers. Now, we have a mathematical way of finding outliers, okay? And it has to do with that interquartile range. Are you ready? It's going to look crazy, but trust me, it's actually not that hard. It's not that hard at all, especially if you have a calculator. I hope you've got one handy. I have mine. So an outlier is typically calculated by multiplying your interquartile range by 1.5. And then determining if any of the data values are greater or lesser than that distance away from my first quartile or my third quartile. So for example, I calculate the interquartile range, no problem. I multiply it by 1.5, yeah. And then I subtract it from my first quartile to get what we call the lower fence, and I add it to my third quartile to get what we know as the upper fence. Anything that's outside those limits, anything that's below my lower fence or greater than my upper fence, those are outliers. So let's analyze, you already know which one I'm thinking of here. Let's analyze that data set from question 1 to see how outliers can be represented on a box and whisker plot. Are you ready? Let's do this. So I have here this lovely guy. This is worked out for you. So this is what we're saying. We did our 5-number summary, right? 2, 5, 9, 12, and 32. We did that. We also calculated our interquartile range. We said that was 7, right? So here's how this works. We're going to find our lower fence first. So we said the lower fence was your first quartile minus your interquartile times 1.5. So we said our interquartile range was 7. And we said our first quartile was 5. So we're going to do 5 minus 7 times 1.5. I'm going to grab my calculator. 7 times 1.5. And when I do 7 times 1.5, I get 10.5. So now 10 minus, I can do this. I have 5 minus, Miss Scott. Write it right. Oh my gosh. So I now have 5 minus 10.5. And if I grab my calculator and do 5 minus 10.5, I find out that my lower fence is negative 5.5. Looking at my data, I don't have anything less than negative 5.5. So we're cool on the lower fence. Let's now talk about our upper fence. Our upper fence is the third quartile plus our interquartile range times 1.5. So my third quartile was 12 plus 7, which is our interquartile range, times 1.5. I already used my calculator and found that 7 times 1.5 is 10.5. So 12 plus 10.5 gives me 22.5. And yeah, that 32 is greater than my upper fence. So this tells me that I have an outlier, that 32 is an outlier. All right, so I now know that 32 is an outlier. So that means my whiskers, we're going to shift things a little bit. My whisker will now end at the lowest or highest value that is not an outlier. So my whisker originally ended at 32. But now, since we're like, dude, 32 is an outlier, he's a weirdo, throw him out. So now we're going to be like, okay, not you, buddy, not 32. And I'm now going to make my whisker end at 14. All right, I'm going to make my whisker end at 14. But I don't want to totally ignore the fact that there's an outlier. So I'm going to put a little star to mark my outlier. The other thing to keep in mind is once your outlier is removed, it may very well change your 5-number summary. I'm going to show you what I mean. So let's say we take out 32. I'm like, not you, buddy. And he's going to get a little star on 32. And I'm like, dude. But this now changes parts of my 5-number summary. My minimum is still 2, right? That's cool. But my maximum is now 14. So my minimum is 2, my maximum is now 14. But check it out, my median changed. Because the middle of this is now between 7 and 9. You know what's between 7 and 9? 8 is between 7 and 9. So my median changed to 8. Did it change my quartiles? I don't think it did. 1, 2, 3, 1, 2, 3. Oh, no, my quartiles didn't change. I still have quartile 1 is still 5. What about this quartile? Did it change? 1, 2, 3, 1, 2, 3. No. Okay. Oopsie. Sorry, just kidding. So it looks like my third quartile is still 12. So do be careful. It might shift some of your 5-number summary a little bit. Really, the one it's going to affect is obviously your maximum, but it could affect your median as well. So it shifted my box and whisker plot just a little bit. You can see my lower fence is down here, my upper fence is here, and that 32 is now just a little star. So in a box and whisker plot, it's common to denote your outlier with an asterisk with a little star out there. Sorry, 32. Dude, I'm telling you, that guy was weird, okay? He was weird. So can you recalculate, since we changed our first quartile and our third quartile, I guess our first one didn't change, our third quartile changed. Can you recalculate the interquartile range now that we've removed the outlier? Go ahead and hit pause, work that out, hit play to keep going. So remember interquartile range, third quartile minus the first quartile. First quartile didn't change, and actually our third quartile didn't either. It was still 12 and 5, so my interquartile range is still 7. So was our interquartile range affected by the outlier? And do you think that's always going to be true? Go ahead and hit pause, jot it down, hit play to keep going. So my interquartile range was not affected by my outlier, and I don't know that that would always be true. It was true in this case, but it may not be true in all cases. My interquartile range didn't change in this data set because I had a lot of duplicate values, right? I had like 5, 5, 5, and I had like 12, 12, 12. But that may not always be the case, so keep an eye out for that. Removing your outliers can affect your interquartile range, so keep a watch out. All right, activity 2.2. Let's keep going with this whole using that interquartile range to identify your outliers. It's helpful. Coach Peterson's Middletown High School football team is struggling to win games this season. It's been rough. He is trying to determine why his team has only won a few times this year. So the table, here we have this lovely table, shows the points scored in games in 2016 and 2017. The box and whisker plots represent and compare the data in the table. So we have our 2016 data and our 2017 data. They're right on top of each other. So looking at these, and again, the table's great, but I know it might be a little more useful to use the box and whisker plots. Which year do you think was better in terms of points scored? Go ahead and hit pause, jot down your thoughts, hit play to keep going. So I'm noticing that my interquartile range, which is my box, hopefully you figured that out, that the box of the box and whisker plot is your interquartile range. It feels like that's a little bit bigger than the box of my other box and whisker plot for 2017. So I don't know. I think maybe 2016 was better in terms of points scored, right? They didn't score as low as they were in 2017, and I feel like that box was a little bit bigger. But you know what? Now that I'm looking at it, maybe 2017 was better because check it out. They had some higher scores, right? Look, they went all the way up to 45. So maybe 2017 was better in terms of points scored because the team had a game with the highest number of points scored that year. They had a game where they scored 45 points in 2017. That didn't happen in 2016. So I feel like maybe we need a better way of looking at this, right? Because you could argue for 2016 or for 2017, right? So what I'd like you to do, go ahead and start by calculating and interpreting the interquartile range for the points scored each year. And what does that interquartile range tell you about which year was better? Go ahead and hit pause, jot it down, hit play to check your work. So first of all, I'm going to come back here. I need my pictures. We said quarter one compared to quarter three minus quarter one. So real quick, I did do some work here to do my guys, right? So here's my maximum, here's my minimum. Where's that median? How many games are played? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Ooh, okay. 1, 2, 4, 5, 6, 8, 9, 10, 11. So 1, 2, 3, 4, 5. Okay, here's the middle. Sorry, guys. I was trying to find the middle. So here's my median. Yay. So this is my median. Oh my goodness, the lights keep going out on me. So this is my median, and that means that my quartile 1 is going to be right here. I'm going to grab a calculator halfway between 20. What's the average of 17 and 20? Average of 17 and 20 is 18.5. So it looks like quartile 1 is 18.5. And that means my third quartile sits between 27 and 28. That one's easy. That's 27 and a half, right? All right, so for 2016, I got my numbers. So I'm going to do my third quartile minus my first quartile. So 27.5 minus 18.5, and I got a 9. So the middle 50% of points scored have a range of 9 points. So we scored between 9, all of our scores were within 9 points there, the middle half of our data. Let's go take a look at 2017. For 2017, again, we have, this is our minimum, this is our maximum, so this must be our median. Hey, it's the same as 2016. Look at that, 24 points. We got to find those quartiles though. So if we're talking quartile 17 to 17, our first quartile is 17 then, that made things easy. Our third quartile is between 24 and 25, so that'd be like 24 and a half, right? All right, and so again, let us go ahead and subtract. So we're going to do our third quartile minus our first quartile. 24.5 minus 17 gives me about 7.5. So this tells me, again, that the middle 50% of points scored have a range of about 7.5. So using the interquartile values, the team was more consistent in 2017, weren't they? 2016 had a bigger interquartile range. 2017, they had it kind of a little packed in and down there. All right. So what I'd like you to do now is I would like you to find any outliers. Take a look, use that interquartile range to determine any outliers for the data, and if necessary, if you do find outliers, reconstruct your box and whisker plot. So make sure you compare that interquartile range of the original data with your new calculations. Remember, we said it could change on you, so watch out for that. Go ahead, hit pause, find your outliers, and reconstruct your box and whisker plots if necessary, then hit play to keep things going. All right, people, let's start with 2016, shall we? So we said that the interquartile range was 9, and we also said that our first quartile was 18.5. All right, so if we recall, we said that the formula was, okay, for quartile 1, pardon me, I can do this. Oh my goodness. Only if I can write things right. So for our lower fence, we said we're going to do quartile 1 minus our interquartile range times 1.5. All right, so for 2016, we said our first quartile was 18.5 and our interquartile range was 9. So I'm going to pop those in there. I have a lovely calculator to help me out. 9 times 1.5. I got 13.5 here, so I'm going to do 13.5. So if I do 18.5 minus 13.5, turns out there's all kinds of things going on here. So it turns out, I'm going to ignore that phone, guys, because I'm not doing this video ever again. So it turns out if we subtract those, that we find out that our lower fence is 5. We now need to do the upper fence. So if you recall, the upper fence, just kidding. I know, things are being revealed. The upper fence was quartile 3 plus our interquartile range times 1.5. So we already discovered 9 times 1.5 is 13.5. That one wasn't a surprise to us. I'm going to add it to my third quartile, which we found was 27.5. So 13.5 plus 27.5 means that we get an upper fence of 41. Now, when I go back and I look at the table, I'm noticing, let me come back and look at that table. We're going to come back and look at that table. I'm noticing that my lowest score was 10 and my highest score was 35. They're within the fence. Yeah, they're within the fence, aren't they? So I don't have any outliers here. My lowest score was 10, which is, within the lower fence. My highest score was 35, which is within the upper fence. So yeah, 2016 had no outliers. I don't have to change that box and whisker plot. Let's look at what's going on with 2017. So with 2017, again, we're going to use these same formulas. Now for 2017, our first quartile was 17, and we found that our interquartile range was 7.5. I'm going to grab my calculator here. 7.5 times 1.5 means that we have 11.25. And if I subtract those, thank you, Mr. Calculator, I get 5.75. So that's my lower fence, 5.75. My upper fence, let's see, my third quartile was 24.5. And we already know 7.5 times 1.5 is 11.25. We just did that. And if I add those together, I get 35.75. Now, can we come back and look at the table real quick? So it's got to be between 5.75 and 35.75. Anything outside of that is going to be an outlier. So I'm going to come back to my table. Oh, crud. We have a day that we got 0 points. Ouch. And we've also got one day where we had 45 points. Those are both, that's below the lower fence. 45 is above the upper fence. So guess what, guys? We've got 2 outliers on 2017. Yep, we have 2 outliers. So this means we're going to come back to that table. We're going to do back and forth a lot here. So I'm going to come back to this table. So here's what that means for us. Because I've got a couple of outliers here, I'm going to grab another color. So this means I've got to check out these 2 guys. He was below the lower fence. He was above the upper fence. So now my minimum is 7. My maximum is 27. My median did not change. The middle is still right here. It's still 24. But check it out. My quartiles changed. If this is my minimum and this is my median, 17. Ooh, okay. So my first quartile is cool. We're cool. So quartile 1. My third quartile changed a little bit, just a little. So my third quartile is now a straight 24. So we're going to need to adjust our box and whisker plot a little bit, okay? Just a little bit. So we said 2016, his box and whisker plot is not changing, but my 5-number summary changed a little bit. My minimum changed, maximum changed, and so that changed my whiskers, and my third quartile changed. First one didn't, but the third one did. So we're going to adjust a little bit. 2016 didn't change. So I'm going to put 2016 back where it belongs. That's fine. Ooh, I should probably put numbers on my number line, right? That would be a good thing. Hang on. I'm going to put numbers on my number line. I'm always forgetting something today. It's all good. So what do we have? 0, and it looks like we counted by 5, 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. All right, so we're going to adjust our 2017. So now we're saying that the minimum is 7. So now we're saying, hey, my minimum's down here. We're saying that our first quartile is at 17, so right about here. Our median is still at 24, so that is the one thing that didn't change there. Third quartile, oh dear, our third quartile is also at 24. This is going to look funky. That's okay. And our maximum is now at 27. Oh my. So my box kind of ends up like this, and I got a whisker and a whisker. The other thing to note is we do need to put asterisks for our outliers. So I'm going to be like, there's one outlier, and then 45, 40, that says 42. That should say 45. And then my other outlier is out here at 45. So it did change a little bit. Kind of squished my box, squished my interquartile range. Oh, and it does say to compare the interquartile range. My interquartile range changed as well, didn't it? Not a ton, but it changed a little bit. It changed to 7. It changed a little. Well, okay then. Oops, just kidding. Last thing, analyze the box and whisker plots with those outliers removed and compare. Do a new comparison. Now that we've pulled out those outliers, compare your 2 box and whisker plots. Hit pause to do that, and then hit play to keep the discussion going. So with the outliers removed from my 2017 data, I can now see that 50% of my data falls between 17 and 24 points. And my median is also 24, which is kind of interesting, but it's because we had multiple games where we got 24 points. So half of my data is sitting between 17 and 24. And of course, that 2016 data didn't change. Half of my data is sitting between 18.5 and 27.5. And it also has a median of 24 points. So this makes me feel that 2016 was a better year in terms of the points scored. It had a better interquartile range. It was a better year, right? Because instead of 17 to 24, we're now talking 18.5 to 27.5. It's a little bit higher, right? Our middle 50% was a little bit higher in 2016 if you take out those outliers. As always, guys, I hope you found this helpful. I hope you found this useful. If you have questions, concerns, come talk to me. I'll help you out, and I'll see you guys soon. Bye.